I'm going to be reading out 15 words, and what I'd like to do is to write those words down sort of in that space there so they're fairly legible so people can see them later, okay? And everybody, I'm going to be reading you out 15 words, and I want you to try to remember these words. There may be a test. Would anyone like to hazard a guess as to what this is? Olympics, somebody shouted. Anyone want to be a bit more specific? Brilliant. Opening ceremony of the London 2012 Olympics. This is a very salient memory retrieval cue for me because it transports me back to that happy time in 2012, in the summer of 2012. And I can have that subjective experience that I'm reliving that wonderful opening ceremony unfolding in front of me again. I can see the athletes marching in, hear the music playing, the drummers thumping the drums, and the roars from the crowd. And I can feel the vibration of the stands as the stadium rocks with the music, and smell the explosive from the fireworks that are going off, and it's just like being back there again. Except I wasn't actually there. Like most people, I was sat on my sofa watching on the TV, and I experienced the sights and the sounds through the TV, but I only imagined the vibrations and the smells because they were described to me by that nice Hugh Edwards off the BBC. And normally, of course, we're very good at distinguishing real from imagined experiences, though sometimes that ability can be disturbed, both in the healthy brain and in people with psychiatric disorders like schizophrenia. And in this discourse, I'll try to explore the brain mechanisms that are responsible for the subjective experience of remembering, and how we use it to make sense of the world and to keep basically a grip on reality. If you Google what is memory, you get about 37 million results. And I don't think any really capture the essence better than this quote by the Roman orator Cicero from around 55 BC, who was clearly considering the Twitter generation in getting his aphorism down under 140 characters. But he's right, memory is indeed the treasure house of all things. Everything we know, everything we think, everything we're conscious of, develops or is influenced or is shaped by our experiences. In many ways, memory is central to understanding ourselves as individuals with a past and a present and a future. And without memory, every moment would be a new experience, as is shown in people with amnesia. The link between memory and awareness and consciousness and subjective experience is strikingly apparent in Clive Wearing, who's a man with very profound amnesia. Clive was a noted musician and musicologist and conductor who contracted a virus that attacked a region in the middle of the temporal lobe of the brain, called the region called the hippocampus. He lacks the ability to form new memories as a result of this and has only moment-to-moment consciousness, believing every few seconds that he's just woken up from a coma. And yet memory and conscious awareness don't always go together. Clive appears to have an intact unconscious memory. He retains the ability to play and conduct music to a very high level indeed, as this short video shows. So evidence from people with amnesia like Clive shows how medial temporal lobe structures like the hippocampus are critical for conscious long-term memory, but not for unconscious long-term memory. Clive was still able to play music to a very high level. He still remembered his wife and had a very firm, obviously very strong emotional attachment to his wife. But the hippocampal damage that he suffered seems to have completely destroyed his long-term memory abilities, his conscious long-term memory abilities, more or less completely. So Clive has no objective, measurable memory, and also lacks any subjective experience of remembering. As Oliver Sacks once wrote in a New Yorker article on Clive, memories just disappear into the abyss. So one thing this means is that studying the hippocampus is unlikely to reveal much about the brain mechanisms responsible for subjective aspects of remembering. But But of course, we know that no brain region really works in isolation. Functional brain imaging reveals that networks of brain regions support all of our cognitive abilities, and memory is no exception. And recent evidence suggests that two other regions that are part of the memory network might be important for subjective aspects of remembering. I'm going to show you, so you can see up on the screen these regions. I'm also going to show you with a real live brain that I just recently removed from a willing audience member. So if I show you, we're going to try something here by putting this on. Let's see if this works. If the technology doesn't defeat me. Oh, there we go. Okay, so hopefully you can see that. Right, so the regions that we're very interested in here are the frontal cortex, which is this region here, the front of the brain, and particularly this region at the front, the very front, this region just behind your forehead, which is called the anterior prefrontal cortex. And another region that we're going to be talking about is a region further towards the back, this region here, which is called the parietal lobes. This is a region just behind and above your ear. And then the region that was damaged in Clive is a region of the temporal lobe right in the middle here, the medial part of the temporal lobe, called the hippocampus. And that's the region that tends to be most damaged in patients with amnesia. So these are the three regions that we're going to be talking about, and particularly the lateral parietal cortex, this region up behind the ear, and then the anterior prefrontal cortex, this region just behind the forehead. And to investigate the role of these regions and the contribution they might make to subjective aspects of remembering, we first need to think about what information processing operations might be necessary for generating our subjective experience. So what exactly is the subjective experience of remembering, and how might we begin to understand it? The study of subjective experience, of consciousness and awareness, dates back to Freud and beyond, and yet its scientific investigation has largely been neglected. Psychologists and cognitive neuroscientists have discovered a great deal about the cognitive and brain mechanisms that enable us to recall a shopping list, for example, but considerably less is known about the processes underlying the subjective experience of reliving a previous event, and as if it's happening in front of us again. So why is that? Why the neglect? In part, it's because it's really hard to gain insight into what somebody's experiencing inside their heads. Even our most sophisticated functional imaging technology doesn't allow us to look at the brain and understand what that person is experiencing. Indeed, scientists have struggled even to know what questions to ask in order to be able to tap into that experience. And one strategy that I've begun to explore with my colleagues Charles Fernyhough and Raphael Line, among others, is to look for inspiration from novelists and poets and philosophers, many of whom have spent their whole lives thinking deeply about the nature of subjective experience. And this interdisciplinary approach has proven to be quite valuable in highlighting some key characteristics of remembering that we can then test empirically using psychological methods or cognitive neuroscience methods, and begin to shed light on what the cognitive processes and the brain mechanisms are that are responsible for that subjective experience of remembering. So one key characteristic is the realization that recalling a memory is not like picking a DVD off the shelf and just playing it, but rather is an act of reconstruction. Quoting from Marcel Proust is a bit of a cliche in a talk on memory, so this is the only time I'm going to do it. But it does give me an excuse to show one of my favorite photos of all time, which is Proust playing air guitar with a tennis racket. Proust was also one of the first to describe the reconstructive nature of memory in his epic 3,000-page treatise on remembering, which is called In Search of Lost Time. I'm not going to read from the whole of the 3,000 pages, but I've just picked this quote here. Remembrance of things past is not necessarily the remembrance of things as they were, which captures the essence of this reconstructive nature of remembering. This is also captured by this quote from A.S. Byatt, who captures the essence of memory as something that's influenced not just by how we might encode it into memory, but also it can be changed and distorted by the way it's remembered. She characterizes remembering as an act of reconstruction, as storytelling. What is remembering? I know that I have added to this memory every time I've thought about it or brought it out to look at it. It has got both further away and brighter, more and less real. In this way, the subjective experience of remembering can be thought of as our way of telling ourselves stories about the events we've experienced. Stories that allow us to think not just about what happened, but how and why it happened, and to learn from that in a way that enables us to better understand ourselves and those around us and the world that we live in. Sir Frederick Bartlett, who was the first professor of experimental psychology in the University of Cambridge department that I now work in, published one of the most important books in the history of memory research in 1932, entitled Remembering. And he was one of the first to consider how memory retrieval can be a reconstructive process as opposed to a retrieval process. In one of his experiments, Bartlett asked his 1920s Cambridge undergraduates to read a Native American folktale, and then over hours and days and weeks to repeatedly rewrite the tale from memory. And what he found was that over the repetitions, over the weeks and months, the story would get shorter, with the details starting to be lost, but the gist of the story tended to be retained. The details either were lost completely or were altered, distorted to fit the student's Edwardian culture and social environment, with details added from stories that were more familiar to them. Hard-to-interpret items would be omitted altogether. And so in this way, our memory is distorted by our thoughts and our expectations at the time of retrieval. This is another quite striking example from Bartlett's book, where he describes this experiment in which people were asked to repeatedly reproduce an abstract drawing from memory. Over repetitions, you can see how the details are lost, but the gist is retained, with the drawing gradually becoming more consistent with the generic schema of a human head. Okay, we're now going to do a bit of a demonstration hopefully, of this effect. This is going to be some live science here, where hopefully we're going to see the effects, but given that it's live science, it may not work, but that doesn't matter. So what we're going to do is, first of all, I'm going to ask for a volunteer, someone who has legible handwriting. Is anyone willing to own up to having legible handwriting who'd like to volunteer to come down and write for me? Thank you very much. Do come down. What's your name?
Melinda.
Hi, Melinda. Nice to meet you. I'm going to be reading out 15 words, and what I'd like to do is to write those words down sort of in that space there so they're fairly legible so people can see them later, okay? And everybody, I'm going to be reading you out 15 words, and I want you to try to remember these words. There may be a test. So the words are door, glass, pane, shade, ledge, sill, yeah. House, open, curtain, fantastic, frame, view, you can maybe go up to there now, yeah. Breeze, sash, blind, shutter. Okay, thank you very much indeed. That's fantastic. Beautiful handwriting. Thank you very much. Thank you. Okay, now what we're going to do, so I'm going to ask you some questions about the words that you studied a little bit earlier. And a word is going to come up, and I want you to select yes or no if you think that word was in the original list. Okay? Are we ready? No? Okay. I'll wait a little bit for the technology. So the first word was door on the list. Has everybody voted? Okay, James, you reveal the answers. Is it correct? What do we get? 93% yes, and that is the correct answer. Well done. Fantastic. That's a good start. Well done, everybody. Okay, let's move on to the next one. Was banana on the list? Okay, James, let's reveal. Good. Oh, well done, everybody. Marvelous. You've been paying attention. Well done. Okay, let's go on to the next one. Was window on the list? Okay, James, let's reveal the answer. Excellent. Okay, so let's just have a look and prove whether or not you're correct. So those were the words on the list. Was window on there? No, it wasn't, ladies and gentlemen. Science, isn't it wonderful? So a significant proportion of you thought the window was on the list because memory typically works by remembering the gist of a situation rather than its details. So we tell ourselves the story that we heard a list of words that were kind of vaguely related to windows, so that we falsely think that window must have been on the list, when in fact it wasn't. And that sort of gives this example of how memory is this reconstructive phenomenon, where we're thinking on the fly as we're retrieving a memory. Another key feature of remembering is exemplified in these extracts. So for many people, memories can be vivid sensory experiences, whereas others report much less mental imagery. There's a great deal of individual variation in that. But among those who do relive past events, memories tend to be primarily visual. But T.S. Eliot here emphasizes how our most important memories can often be multisensory, combining sights, sounds, smells, etc. Why, for all of us, out of all we have heard, seen, felt in a lifetime, do certain images recur, charged with emotion, rather than others? The song of one bird, the leap of one fish, at a particular place and time, the scent of one flower. Similarly, Virginia Woolf captures how a multisensory experience, often remembered very much from a first-person perspective, tends to characterize many people's most vivid, most emotionally salient memories, those that we often have the most confidence in. Virginia Woolf describing her first memory that she can remember. It is of lying half asleep, half awake, in bed in the nursery at St. Ives, hearing the waves breaking, 1, 2, 1, 2, lying and hearing this splash and seeing this light and feeling it's almost impossible that I should be here, of feeling the purest ecstasy I can conceive. Very evocative. As Virginia Woolf highlighted, the self-referential nature of our most important memories is another key characteristic. As the great philosopher, psychologist William James wrote, memory requires more than mere dating of a fact in the past. It must be dated in my past. In other words, I must think that I directly experienced its occurrence. And this extract from Wordsworth illustrates how our memories are tied closely to us, the person who originally experienced the event, and we typically relive them from our original point of view, a first-person perspective. Oh, many a time have I, a 5 years child, a naked boy in one delightful rill, a little mill race severed from his stream, made one long bathing of a summer's day, basked in the sun, and plunged and basked again, alternate all a summer's day, or coursed over the sandy fields, leaping through groves of yellow groundsel. Part of the reason I think that this is such a powerful depiction is the use of the first person, so we can see it through the poet's own eyes. We're going to demonstrate the importance of the self to memory. I need you to get your phones out again. Perhaps we should have stopped at the first one, given that that worked. We're now asking for trouble. Okay. If we can, James, if we can go to the screen. Thank you very much. Okay, I'm going to be showing you some words and asking you some questions about each of the words. Okay? And then we'll be testing your memory for them again. This is a memory talk after all. Everyone ready? Okay, here we go. Does gentle contain the letter E? Who was that? Sorry, you can show them. You can show these ones. Okay, very good. The one person who said no, come and see me afterwards. Does wise describe you? Not so sure about that one. Okay. Does artistic contain the letter E? Okay. Very good. Does lazy describe you? Okay. Good. Does rude contain the letter E? Good. There's still somebody, isn't there? One person. Does reckless describe you? Okay, excellent. Right, well done, everybody. Now we have the memory test. Oh, everyone's heart sinks. Are we ready? Okay, so what I'd like you to do is to select on your screen the words that you think appeared in the list just now. So select all the ones that you think were present. Everyone made a response who wishes to? Okay, James, we can reveal the answers. Okay, that's very interesting. So if you could show the correct answer, James, if you could just select that box in the middle, the correct answer. Thank you. So the ones that are highlighted in sort of bold there are the ones that you referred to yourself, that you did the self-referential processing on. And the other ones are the ones that you just decided whether or not it contained the letter E. So actually, it's worked. What are the chances of that? Wonderful. Thank you very much, everybody. Give yourselves a round of applause, I think so. Now, we remember events that are related to ourselves better because we encode them into memory more deeply by relating them to our highly developed self-concept, compared to the relatively shallow processing that's associated with deciding whether a word contains an E or not. Now, this self-reference advantage can also be seen in terms of the perspective with which we remember events. So if you think back to your most important memory, it might be your first day at school, or your wedding day, or the birth of your first child, perhaps. Do you envision the scene from a first-person perspective, from the same point of view as you originally experienced the event? Or do you see yourself in the scene, viewing it as a detached observer from the third person, or perhaps from above, as in this figure? The chances are that for your really important memories, you re-experience them from a first-person, egocentric perspective, rather than a third-person, allocentric perspective. And Sutton and Robbins found that first-person autobiographical memories tend to rate higher on things like vividness, the coherence of the event, sensory detail, the amount of detail involved, and the amount of emotional intensity associated with the memory. Whereas remembering the objective circumstances of an event tends to lead to relatively more third-person memories, a focus on feelings and emotion tends to lead to more first-person memories. Interestingly, two types of memories that researchers have found often to be experienced from a detached third-person perspective are giving an individual public presentation and walking or running from threatening situations, both of which I'm currently experiencing. An out-of-body experience. So to isolate the brain mechanisms of subjective remembering, we're looking for regions where damage does not cause total amnesia, as in Clive Wearing, but regions that support processes that imbue our reconstructed memories with vividness and precision and confidence, integrating event features, perhaps across different sensory modalities, into a first-person perspective representation. So which brain regions might be important for those processes? With the advent of neuroimaging, a lot was learned about how regions beyond the hippocampus, the region damaged in Clive and patients, other people with amnesia, how there are other regions that are involved and that contribute to memory. And in particular, something was learned about the parietal lobe, region of just behind the ear and above the ear, and in particular a region of the parietal lobe known as the angular gyrus. This region came up very, very frequently in functional brain imaging studies of memory, even more frequently than the hippocampus, indeed, for a long time. And this was a surprise because patients who have parietal lobe damage are not generally thought of as being amnesic. But perhaps memory was never properly tested in such patients, and this damage to this region might cause memory impairments that were missed before. So we tackled this question a few years ago by first asking healthy volunteers to come into the functional brain imaging scanner and perform a task in the scanner that involved recollecting details about the context in which they'd studied words or they'd studied famous faces. And when we did that, we found patterns of activity. Recollecting words was associated with activity. These yellow dots are the activity in the healthy volunteers, these blobs. So activity here this is the left hemisphere of the brain. This is the left parietal lobe around the angular gyrus. So activity in the left parietal lobe when people were recollecting words, and bilateral activity in both of the hemispheres, both of the parietal lobes, the left and the right, when people were recollecting famous faces. So then what we did was we went to a database that we have of patients who have suffered strokes and other kinds of brain damage that affects these exact same regions. And we selected those patients whose lesions closely overlapped the patterns of activity that were elicited by the healthy volunteers. You can see these areas in purple and green here that closely overlap with the left region of activity and lesions that overlap with the right area of activity. So if those specific parietal lobe areas are necessary for recollection, then patients with left parietal lobe lesions should show amnesia for words, and patients with right parietal lesions should show amnesia for faces. As you can see, however, that's far from what we found. So the performance of healthy control volunteers is shown in blue, and then performance of the left patients with left parietal lobe damage in red, and performance of patients with right parietal lobe damage in green. And you don't really need statistics to show that the patients were not only not amnesic, but their recollection was pretty much as good as healthy control participants, despite their brain damage apparently closely overlapping the areas that healthy volunteers were engaging when they were doing the exact same task. So these patients are definitely not amnesic, but it's also not the case that their memory is completely normal. Talking to them, and many of the best experiment ideas come from just talking with patients. They say, well, I can remember whether something was on the left or the right of the screen, or if it was a male or a female voice that read a word out or something, if you ask me. But I'm not very confident about it. And I can't see that event unfolding in my mind's eye in the way that, that I would describe to them. And indeed, when asked to rate how confident they were in each recollection response, patients tend to show reduced subjective confidence in the vividness and the precision of each of their accurate memories. So their accuracy is just as good as healthy controls, but their confidence in those accurate responses is significantly reduced. We recently sought to isolate these effects using a technique called transcranial magnetic stimulation, or TMS, which is a non-invasive method of temporarily disrupting brain function in specific regions. So Yasemin Yazar disrupted the function of that angular gyrus region of the parietal lobe and compared the effect on memory of disrupting a vertex control site, so somewhere up towards the top of the head. And just as with the patients, disruption of this angular gyrus region, in red here, made no difference to accuracy compared with disrupting the control region, no significant difference. But there was a significant reduction in these healthy volunteers in their confidence in their accurate recollections, just as in the patients. Similarly, Marion Berryhill and colleagues found that patients with parietal lesions are impaired when they're asked to freely recall autobiographical events from their lifetimes. So they're just asked to come up with a memory from adolescence or something, and asked to recall as much as they can about that memory. Their free recall, compared with control participants, was massively reduced in terms of the amount of detail, in particular, the amount of internal detail that are particularly relevant to that memory. So they contain reduced vividness, reduced amounts of detail. These patients appeared not to be subjectively reliving the events, as they told them, in the way that many healthy control participants do. However, again, the patients were not amnesic because when their recall was cued by being asked specific questions about the memories, their memory was completely unimpaired, or statistically unimpaired. They were able to come up with the answer to questions about those memories, even though they couldn't spontaneously come up with them. They couldn't spontaneously recall them because they weren't reliving that event unfolding in front of them again. So what processes underlie this subjective aspect of remembering? As suggested by the literary insights discussed earlier, a key process involves the integration of multisensory memory features into a conscious representation that enables this reliving of the event. And anatomical connectivity data indicate very rich interactivity between the angular gyrus region of the parietal lobe, shown here, and sensory processing areas, regions that process visual information, regions that process auditory information, sound information, and other sensory modalities. And also rich interactivity with memory regions, other memory regions, part of the memory network. So frontal regions of the brain, hippocampus and medial temporal lobe regions of the brain all end up connecting in this kind of hub-like structure of the angular gyrus, where this converging information is perhaps combined and integrated. So to test this hypothesis in terms of memory, Heidi Bonici and Franco Richter asked volunteers to study short clips that were presented either auditorily or visually or audiovisually. So for example, they might just hear an alarm going off, or they might watch a sun rising over the sea silently, or they might watch an ambulance zooming down a busy street with its siren blaring. Then, in the functional brain imaging scanner, participants were presented with one of the words and were asked to recall the clip, report the sensory modality in which it was presented in during the study phase, and to rate the subjective vividness of their memory for that clip. And what we found was that the brain areas involved in processing auditory information, shown here, were reactivated when recalling auditory memories, to a greater extent than when recalling visual memories, for example. And visual processing pathways in the brain, shown here, were reactivated during memory for visual features, more than for auditory features, for example. However, angular gyrus activity didn't differentiate between the auditory and the visual memories, but it did show greater activity instead during retrieval of integrated audio-visual information. And then we used a statistical technique called pattern classification, which tries to decode, if you like, the activity patterns in a brain region that are tied to specific memories. And we found that specific individual multisensory memories could be decoded quite accurately from the patterns of activity in angular gyrus. And what was even more exciting was that the accuracy with which that classifier was able to decode those memory representations tracked the subjective vividness that participants rated their memories with. So in other words, a detailed and precise memory representation in the angular gyrus was experienced by participants as a more vivid memory. However, like confidence ratings, this is based on self-report, on people reporting the qualities of their memory. And we know that self-report measures can be influenced by biases and expectations on the part of the rater. So is it possible to come up with a more objective measure of subjective experience? This, of course, is a very difficult thing to do. One possible objective measure that we've been exploring recently is to test the precision with which people can remember. So Franco Richter and Rose Cooper recently developed a new task using continuous measures of memory to reveal not just whether people can remember something or not, but the precision with which they're able to remember. So people studied displays that each contained 3 everyday objects like this, and the objects were overlaid on a scene background. And each object was assigned a random location on the scene, and a random orientation, and a random color. So they could be anywhere on the screen, they could be any which way round, and any color of the rainbow. And then after studying a set of such stimulus displays, people's memory is tested by asking them to recreate the features of studied objects by moving a 360-degree continuous dial until each feature matches their memory of it as precisely as possible. and we test memory precision for the three features that vary: for the orientation that people think the item had, its location, and the precise color of the object. When people did this task in the functional brain imaging scanner, we found that hippocampal activity determined whether or not they remembered anything at all about an object. When they did remember an object, activity in the angular gyrus, the region just behind the back of the ear, tracked the precision with which they remembered it. So we're currently excited about the potential of these continuous measures of memory precision for providing a much more sensitive measure of memory than traditional approaches that just differentiate between yes or no, or whether someone's successful or not successful. This raises the prospect of perhaps being able to detect very early signs of age-related memory vulnerability, for example, in middle age, which might mean that interventions could be employed that might maintain or even perhaps enhance memory abilities before they're lost. This is something we're exploring in research that's going on in the lab at the moment. What about the other element that's so crucial to subjective experience, which is this first-person perspective nature of memory? Evidence from the spatial navigation literature, people who study the brain's GPS, find that allocentric map-based navigation activates the hippocampus, as shown in this study by Zale et al. Whereas parietal regions are involved in the egocentric first-person perspective types of navigation. So does this mean that these parietal regions contribute this first-person perspective component of reminiscence that imbues our memories with such salience and vividness? This is some hot-off-the-press data from the lab suggesting that it might just. So Heidi Benici used transcranial magnetic stimulation to see what happened to people's autobiographical memories when angular gyrus was disrupted. We were first able to replicate Marion Berryhill's findings from the patients that I talked about earlier, that the free recall of autobiographical memories is reduced after stimulating angular gyrus in a healthy volunteer compared with stimulating a control region. But the memories are intact when recall is cued with specific questions about the events. What was fascinating, though, which is the graph here, is that fewer autobiographical memories are reported as being experienced in the first-person perspective after angular gyrus disruption, compared with this other control region disruption. So that suggests that angular gyrus is indeed critical for tying our memories to us, the person who originally experienced the event. So the lateral parietal lobe, and the angular gyrus in particular, seems to help to integrate event features into a vivid first-person perspective representation that enables this subjective experience of remembering. But why does our brain bother to conjure up a subjective experience of remembering? What is its adaptive value? The great memory theorist Endel Tolving has proposed that subjective experience, what he called autonoetic awareness, allows us to reflect on the content of our memories, to understand and make judgments about the things that we remember, such as the critical ability of distinguishing events that actually occurred from those that we might have imagined or been told about by somebody else. And we've been studying the processes involved in distinguishing real from imagined events and finding a role for the anterior prefrontal cortex, this region just behind your forehead, in that ability. This quote from Byron captures the dilemma of not being sure whether a memory is real or imagined. It is singular how soon we lose the impression of what ceases to be constantly before us. There is little distinct left without an effort of memory. Then indeed the lights are rekindled for a moment, but who can be sure that imagination is not the torchbearer? And although we're normally pretty good at distinguishing real and imagined events, we can all from time to time be prone to that moment of confusion where we think that something we dreamt about actually happened, like me opening the bowling for England, for example, or where we're unable to remember whether we locked the front door when we left home or just thought about locking it. Such confusion can be particularly debilitating in psychiatric conditions such as schizophrenia, in which a person's relation to reality can be altered in ways that can, of course, be very disruptive to their everyday functioning. The doyenne of memory research, Marsha Johnson, has coined the term reality monitoring to refer to the processes involved in distinguishing real and imagined events from one another. She's proposed that mental experiences don't come with tags that specify them as being real or imagined, but that we make judgments about their origin at the time of retrieving a memory by considering the features that we're retrieving in the light of what we expect real and imagined experiences to be like. We might expect memories of real events to be full of externally generated perceptual details, such as where and when an event occurred, who else was there at the time, who said what to who, etc. Whereas imagined events might comprise traces of internally generated thoughts and feelings and mental operations to a greater degree. Now, work I was involved in with Paul Burgess and colleagues at UCL a while ago identified that anterior prefrontal cortex might be important for switching attention between thoughts and perceptions when performing difficult problem-solving tasks, for example. So perhaps this region is also recruited when distinguishing between internally and externally generated memories. Here's an example of one of the tasks we used to test reality monitoring. So in a study phase here, people study everyday word pairs, Laurel and Hardy, bacon and eggs, etc., etc. Half of the time, they are presented with the whole word pair and have to read the whole thing out loud. And half of the time, they're presented with the first word and a question mark, in which case they have to imagine the second word that completes the word pair, and then read the whole word pair out aloud again. And in half the trials, the subject does this, and in half the trials, the experimenter does this. And both those two factors are obviously varied across the experiment. And then in a test phase, people are shown the first word of a studied word pair and asked to make some kind of an internal versus external judgment about their memory of it. Did they see or imagine the second word of the word pair? Or was it themselves or the experimenter who read that word pair out aloud? So different kinds of internal versus external kinds of distinction. And when they're asked these questions in the functional brain imaging scanner, the only region of the brain that consistently shows significant activity is the anterior prefrontal cortex, this region here. So this is the sort of frontal lobes of the brain here, and then this is the anterior prefrontal cortex, the region just behind your forehead at the very front of the brain. Now, if you don't believe me, and you should indeed be skeptical, since we're all concerned about how reproducible scientific results are these days, this shows that the effect replicates across different labs and across different kinds of reality monitoring tasks. So this is when people are remembering lots of different internal versus external kinds of distinctions, but you can see how consistent that anterior prefrontal cortex activity is. Now, we can all confuse real and imagined events from time to time, but reality monitoring performance on the kinds of tasks that we carry out in the lab varies considerably, even in apparently healthy individuals. So this graph shows the performance on one or other of our reality monitoring tasks of around 150 random participants who came into the lab. These are all healthy volunteers who are contributing to our science, and we're very grateful for them for doing so. They all perform absolutely normally on every other task that we give them, tasks tapping all kinds of different cognitive abilities, and indeed, most memory tasks that we give them, these participants perform absolutely typically on. But whereas some of these people find these reality monitoring tasks apparently very easy, others seem to find it far more difficult. And so we wondered, after seeing these sorts of data, this variability, could it be due to something that's going on in the anterior prefrontal cortex of these people? We know that people activate this region when they're performing the task. Is there some variability in this region that might be associated with the individual differences that we see here? So Marie Buda studied a region called the Paracingulate sulcus, which is a very well-characterized brainfold variation in the middle part of the anterior prefrontal cortex. It's what's called a tertiary sulcus, which means it develops very late in gestation, and it's very prominent in around half of the general population, with its variability perhaps due to a combination of genetic and environmental factors. So Marie classified healthy volunteers who came into the lab to perform our reality monitoring tasks based on their structural brain scans into groups with a prominent paracingulate sulcus in one or both hemispheres, or a group who had complete absence of the paracingulate sulcus in both hemispheres. And And what she found was that people whose paracingulate sulcus was absent in both the left and the right hemispheres exhibited significantly reduced reality monitoring performance compared to all the other healthy volunteers who had a prominent paracingulate sulcus in one or both of their hemispheres. These were all typical healthy volunteers who showed normal performance on other tasks that we gave them, and certainly didn't think they had any memory difficulty. And indeed, they actually didn't have any memory difficulty apart from making these specific judgments about real versus imagined types of events. Now, disturbed awareness of what's real may also underlie some of the symptoms of clinical conditions like schizophrenia, such as hallucinations, for example, which many patients with schizophrenia experience sometimes on a very frequent basis, can be extremely disruptive to their lives. And it's possible to consider hallucinations as resulting from the misattribution of imagined information as having occurred in the outside world. So you imagine a voice conveying a message to you, but you misattribute it as being a real voice coming from a person or from the radio or from something in the outside world. And this image shows how there's a close overlap between the brain areas that tend to be dysfunctional in schizophrenia, which are shown as green spheres in this image, and the areas that show activity in healthy volunteers when they perform reality monitoring tasks, which are these yellow dots. Hopefully you can see the very, very close overlap between those two different kinds of independent data. And so this close overlap supports the idea that disrupted reality monitoring might be responsible for the experience of hallucinations that many people with schizophrenia are plagued by. Jane Garrison really recently tested whether paracingulate sulcus length might predict the occurrence of hallucinations in schizophrenia. She compared people with a diagnosis of schizophrenia who had a history of hallucinations against people whose schizophrenia diagnosis was due to other diagnostic symptoms, such as thought disorder, for example. But these people had never actually experienced hallucinations. And what she found was that there was no difference or no significant difference in the length of the paracingulate sulcus between healthy matched control volunteers and patients with schizophrenia who had never hallucinated. There was no difference in terms of their paracingulate sulcus length. But that the length of the paracingulate sulcus significantly differentiated patients with a diagnosis of schizophrenia who hadn't hallucinated from patients who had hallucinated. Patients with a history of hallucinations had a reduced length of the paracingulate sulcus. This is a very fascinating finding. This is a tiny brain fold in the medial part of the anterior prefrontal cortex, and it seems to be that that's the only region of the brain, because we did other analyses to look elsewhere in the brain to see whether there was anything else, any other regions that differentiate between these two different patient groups, and there wasn't. This was the sole region that differentiated between those who hallucinated and those who didn't. And these patients were matched on every other factor that we were able to match them on. And so it seems that this region is not only crucial for those reality monitoring processes, its ability to differentiate real from imagined information, but if this region is disrupted in some way, then that ability is reduced, and people have greater propensity to experience things they imagine as being real, and experience a hallucination. So to summarize, I've talked about the contribution of three key components of the brain's memory network. So the hippocampus, we think, plays a role in constructing an allocentric representation that comprises the core features of a memory and that determines whether we remember something at all or not. The parietal lobe then integrates multisensory features within a first-person perspective, helping to create that subjective sense of reliving a past event, experience it all over again as if it's unfolding in front of us. And then the anterior prefrontal cortex is among regions that use those representations to make decisions about our memories. For example, distinguishing events that actually occurred from those we might have imagined or been told about. And together, these regions generate that subjective experience of remembering, which for many people is such a rich and vivid part of our mental lives. So I'd just like to finish by thanking all the people in my lab, many of whom are here this evening. Thanks very much for coming along. They did all the great work, and I couldn't have done any of this without them. Thank you very much also to the people who are kind enough to fund our research. I hope they continue to be kind enough to fund our research. And thank you very much for coming. Thank you.